About 4,500 years ago, ancient builders erected a megastructure so massive it has survived millennia of scorching summers, torrential rains, and earthquakes. The Great Pyramid of Giza is an absolute anomaly of human engineering. But to really grasp its scale, you have to look closer. This monument is built from millions of individually carved, massive rectangular blocks. Together, these stones weigh an estimated 6 million tons. For context, the tallest structure in the world today, the Burj Khalifa, weighs a mere 500,000 tons. This chart shows exactly what that disparity looks like. The blue bar represents our modern threshold, a huge 500,000 tons of glass and steel. But then you look at the Great Pyramid, and that bar has to multiply 12 times over just to match the sheer volume of rock. And they achieved this without the machinery we rely on today. No bulldozers, no cranes, no iron tools, not even the wheel. If we toss out the myths and conspiracy theories, we are left with the ultimate puzzle. How did human beings actually pull this off? The first step to solving it is clearing up a major misconception. Hollywood often depicts the pyramids being built by abused slaves, but the historical record reveals a well-fed, highly skilled national workforce of 20 to 30,000 citizens. Their first physical barrier was extracting millions of tons of solid limestone and granite from the earth, entirely without the help of iron. Instead, the stonemasons relied on relatively simple equipment. They used tools just like this, a basic copper chisel and a wooden mallet. To break the hardest granite, they took advantage of the rock's natural flaws. They would find existing cracks, hammer in dry wooden wedges, and then soak those wedges with water. Wood naturally absorbs moisture and swells. As the water seeped in, the expanding wood generated enough kinetic pressure to split solid rock right open. They were mastering the natural properties of the materials around them, rather than relying on brute force alone. Cutting the stone was only half the battle. Some of the massive granite blocks were quarried in southern Egypt, roughly 800 kilometers away from the construction site. For the long haul, they built heavy rafts and floated the stones down the Nile River, navigating right through the harsh desert environment. The real logistical challenge began once they hit land. How do you drag an 80-ton stone block across loose, dry desert sand without a set of wheels? The answer was recorded in ancient tomb paintings, eventually leading physicists to a major discovery in 2014. This diagram shows what happens when you pour a very specific amount of water, just 2 to 5%, into dry sand. The water droplets form capillary bridges that bind the loose grains together. Instead of piling up and creating a mountain of friction in front of a heavy sledge, the wet sand flattens into a stiff, rigid track. This chemical trick cuts the required pulling force exactly in half. Moving these massive weights across the desert was solved through precise, applied chemistry. Now they had millions of blocks at the base. The final physical barrier was lifting those stones 147 meters straight up into the air. In 2015, archaeologists uncovered a 4,500-year-old ramp system in an ancient quarry. It suggests the builders used a system exactly like this, a long, low-angle slope hugging the perimeter of the structure to allow continuous upward hauling. By lining the edges of the ramp with sturdy wooden pillars, teams of workers could wrap thick ropes around the posts, creating a primitive but effective pulley system to drag the massive weights up the incline. And to finally place the blocks at the very top, they likely adapted an existing agricultural tool. This is a shadoof, a counterbalance lever normally used to draw water from the Nile. By placing a heavy weight on one end of a pole, workers could use the mechanical advantage to help lift and pivot a massive stone block on the other. The construction of the pyramid was effectively a scaled-up application of everyday farming and maritime tools. But just as we start to feel confident in our understanding, we hit a massive mathematical wall. The Great Pyramid is estimated to have been completed in just 20 years. This chart visualizes what that deadline looks like in practice. To move 6 million tons in 2 decades, 20,000 workers had to place a massive stone block every 3 minutes, 24 hours a day, all year round. We understand the mechanics of moving a single stone, but modern modeling struggles to account for how they achieved this aggregate speed over 20 years. Then there is the chemical mystery. Scientists have analyzed the exact chemistry of the earthquake-proof mortar binding the upper stones together. Yet, to this day, no laboratory has been able to synthesize or recreate it. And finally, the design itself. The pyramid's edges point toward true north, east, south, and west, with an error margin of merely 1/15 of a degree, an accuracy achieved thousands of years before the compass or GPS. When confronted with these gaps in our knowledge, it is tempting to look for a shortcut. It's easy to fill the silence with theories about ancient power plants or alien architects. But true scientific rigor means acknowledging the limits of our current understanding, while maintaining a profound respect for the capability of the ancient humans who actually stood on this sand and built it.